Today I am talking with Matthew Cruz. Matthew runs a YouTube channel called Fast F Sharp, where he teaches the principles of performance programming to F Sharp programmers. Matthew comes at programming and performance from a different angle than many members of the Handmade community, but in my view, the Handmade ethos is still clearly present in his work. In this conversation, we talk about how he learned programming and performance programming, whether or not C is a difficult language, characteristics of F Sharp and how performance thinking can be applied to that language. We touch on the idea of domain-driven design and how it contrasts with data-oriented design. And we discuss a little bit about what programmers can do to get better at their craft, along with much more. I think this was a fascinating conversation, and I hope it will provide new insights to you as well. Enjoy. Hi, Matthew. Welcome to the show.
Thank you for having me. I'm excited to be here.
Yeah, I think this is going to be a really fun one. I think, you've got this YouTube channel that first caught my eye because I think you were looking for more resources about learning C stuff, and I wanted to go check out your channel. And your channel is Fast F Sharp for the people listening. And I was immediately struck by how interesting it is that you have, F Sharp, we'll get into this more as we talk about it, but F Sharp is not something that I think the Handmade community would naturally be super excited to hear about, but your videos really showcase the handmade attitude, at least from my perspective, very clearly. And so I thought it was a really interesting thing to see it's being really faithfully brought to a domain way outside of the normal handmade strike zone. So I thought that was really interesting, and I wanted to figure out how that's happening. So I think it'll be interesting to dig into it.
Well, that's really kind. I really appreciate that. That's very honoring for me as an admirer of the handmade community, of the work that you have done. And, in some of our exchanges, I mentioned that I think of myself as very much a beginner systems level programmer. So that's very high praise coming from you. And I'm glad that the handmade ethos is being translated correctly and authentically to F Sharp. So thank you very much. I appreciate it.
Yeah, for sure. So I think to get started, it would be useful to get a little bit of an introduction about you and your background, because you're not just on a journey to learn handmade now, but you've also picked up software development sort of in along a non-standard path. So could you give us a little bit of an idea of where you started before the software development became a part of what you were doing, and how that part of the how you took up software development from your particular path?
Sure. So the first piece of software I ever wrote was QBasic. I think I was 8 years old at the time. I had a friend who had the game Star Control, and I wanted to be able to play it, but we couldn't afford software, and I don't think we had a PC that could even play it. So I'm like, oh, QBasic's on here, I'll program something, and I had triangles flying around. I didn't touch software again until engineering school. So I went to school originally for chemical engineering, and you suffer through some MATLAB there. and suffering is the correct term. Did an engineering internship at Intel. And that is where the spark got reignited, because we had a problem and I was aware of Excel and VBA. And it's like, oh, well, this problem, we could automate this and make this a lot easier. And so I pick up a book on Excel, VBA development, and started building some tools. And so, I'm sure software developers now are just like, no, we created another one. But I think that theme is going to come back, that immediate feedback when writing software is visceral for people. And so that theme is going to come back. Eventually finish the chemical engineering, went and did industrial engineering. For my master's, started doing that. And the problem was that I was working in semiconductor manufacturing, and we had scheduling problems, right? So scheduling a semiconductor manufacturing facility is a brutal problem. And I knew the algorithms that we needed to implement to improve the efficiency, but we did not have a developer available to implement them. And so, fortunately, I had a mentor at the time. His name is Justin, and he kind of helped me get my head around Groovy, of all things. uh, which I really liked Groovy, but from there, I kind of became a quantitative analyst because the term data scientist had not escaped San Francisco yet. And so I was doing lots of work in R. And that's when you reach a point where you write so much code that you kind of get anointed as a developer. And so that's kind of how I made it in. And it was at that point where I was like writing lots of R code and learning about unit testing and like, how do you do this properly? And I also started picking up F# at the time, and the performance of our code started to become really critical. Now, most of our performance problems were related to the database and queries. And so that's kind of where this all started, where I'm like, okay, well, why are our queries slow? And just like, oh, well, what's going on underneath the covers? Oh, these are B trees. Like, oh, this is how data is laid out on the disk. And like, this is how it's paging stuff in and out. And so that's kind of where my curiosity of where I'm writing a language, but like what's going on under the hood? Because I saw that there was massive implications for the performance and then the real world experience of the users of it. And performance is critical. And I know that the handmade community kind of already believes in this. So I'm preaching to the choir a little bit, but for me, why did I care about performance? So currently what I do is I build simulation and optimization tools for enterprises as a part of the consultancy that I work with. If your simulation is too slow, no one cares about it because it's not fast enough to answer questions. And it's funny that I mentioned this because one of the things I work on specifically is discrete rate simulation. And the first version of that was created was slower than the actual manufacturing process it was trying to model. This is hilarious. This was back in probably the early 90s. But performance drives the use case. And so for us, if you have a simulation that can run extraordinarily fast, you're able to explore more scenarios. The more scenarios that you can explore, the better understanding you have of the system and how to optimize that system. So my interest in performance has nothing to do with code quality per se. And I'm addressing that because there's a convergence between kind of like the handmade thinking, but also these very practical use cases where if it isn't fast enough, it doesn't matter. And performance is a key differentiator in the market. So that's kind of where that convergence happened. Now, the way I came upon the handmade community was I had taken my current job at Simulation Dynamics, which is just a very small consultancy doing bespoke simulation optimization work. And we wanted to create a simulation engine for discrete rate simulation, which is this, to give people context for that, there's discrete event simulation, and then there's kind of the continuous time simulation, which is like fluid dynamics and heat flow. Well, halfway between those two domains exists discrete rate simulation. So we wanted an engine for doing this that was far better than what exists in industry. And I'm an F# developer because I kind of came up the analyst skill tree. And so F# was a natural language for me to migrate into, but now I need to go fast. And so I was like, okay, well, what are the fastest pieces of software on the planet? Game engines. So I started saying like game engine architecture. And I have like a bunch of books by like Jason Gregory's book on game engines. And so I was just looking for everything I can on game engines. Like, how do they make stuff fast? And I put out on Twitter, like, hey, does anyone have videos about game engines, game engine development, game engine architecture? And then someone's like, oh, well, you should check out Handmade Hero, Casey Muratori. And I'm like, oh, well, this is cool. And then I go and check it, and like, it's like 600 videos. I'm like, oh, my word. Like, this is crazy. But that's how I came to the handmade community. So sorry for the very long answer, but now we've kind of made it to where I've connected to the handmade way.
Yeah, no, that's great. I think I have actually more follow-up questions on that sort of journey there because well, given us the timeline
Mhm.
of how it happened. Something I'm very curious about since a lot of it sounds like, and correct me if I'm mischaracterizing it, but it sounds sort of like an independent learning journey for the most of it. There may be some mentors along the way too, but a lot of it had to be self-driven, it sounds like. And so I think something that'd be interesting to know more about is for you in particular, sort of what structure does that take? What materials have been the most valuable, or what style of materials? Is it books or videos? It sounds like you've gone and looked at a bunch of those. I'm curious if you have a sense of what your idea is of the best way for you to do the self-learning thing that you've been doing. How does that work best for you?
Yeah, that's a great question. And for me, part of the context is I have dyslexia. And so reading is a useful reference, but it's not always the best first exposure. And so what do I mean by that? Like Pluralsight was a critical resource for me early on because that was one of the few games in town that had lots of video resources related to F sharp and programming in general. The software engineering YouTube wasn't as big as of a thing at the time. Maybe it wasn't, I just wasn't aware. But so video form is incredibly helpful for me. And so like recorded workshops or that kind of content is generally how I like to be initially exposed to ideas. And
Mm-hmm.
then something about that then kind of gives me the overall framework that I need to then go and read a book. And so that has typically been my journey as I'll go search YouTube for a video on something, like I find your channel or Casey or any other people in that space. And that kind of gives me the broader framework. And then a book helps me kind of fill in the pieces of that framework. So I really like using both of those
Mm-hmm.
to kind of complete my knowledge about an area. Blog posts are useful as well. The I find the challenge with blog posts is that I really like having like a physical book and like having
Mm.
some tactile thing to work with. And again, that might come back to the dyslexia because a lot of dyslexia, um, learning to work with dyslexia is about making varieties of connections in your brain. And so a lot of it is doing tactile things. Like I remember writing the letter F on a chalkboard like a million times. And so it's something about like having this like physical medium, like for those listening, I'm like holding this giant book. There's something about that that helps it connect in my brain. So I really value books. And typically by the time something makes it to a book, someone's spent a lot of time thinking about it versus someone just being able to spew a blog post, which are like, I'm not degrading blog posts at all, but there's an additional amount of distillation and editorialization that has gone into kind of condensing these really critical ideas.
Yeah, I think I relate to some extent. I don't know if it's through the dyslexia angle. I don't know that I have that, but I do find that it's a lot harder for me to begin most topics with a book.
Mm.
And I've been puzzling over that for a long time. It seems to me, and this might be an issue with programming books in particular, but I just don't know that we have a great idea of how to go about putting programming ideas to paper super well. And
Mm-hmm.
something like Handmade Hero was, I learned so much so fast that I kind of just clicked into like
Oh yeah.
hearing someone talk and show some code works way faster in my head than trying to get an idea from a book or a blog post. Although I do find like, the nice thing about a blog post is that it can be on a very narrow topic that
Yes.
you don't want a
Yes.
full book about it. And so there's definitely a good spot in the ecosystem for blog posts too. But the video, we'll get into this more later because I'm very interested in it. But the video format seems to me very useful for programming educational materials,
100%.
personally. Yeah.
Yeah. Well, and like you're saying with like the handmade, uh, C, the C programming language was this opaque abyss to me when I started. And it's funny, like I kind of skipped there was this moment in time where I was thinking of switching to computer science because I have a very good friend who was doing computer science at the time, and he saw that I was doing, just like, Matthew, you'd really like computer science. And I was like, okay, like what should I try or something? And like, oh, you should try C. Here's code blocks, the IDE. And I'm just kind of like, what is with these asterisks and ampersand? Like, what is this garbage? Just like totally lost. Because again, I was referencing a book and then trying to take what was in that book and put it into the editor versus Handmade Hero. Casey gets on and you can see what he is doing and him clicking around and making stuff happen and like making fun of the Windows C API and just like, but like seeing it being done is like, oh, okay. Like, okay, this isn't as scary now because there's, I don't know, like, yeah, like seeing it done is very helpful.
I think that raises another point that I was curious to get your thoughts on, which is, the handmade community is constantly interested in figuring out how to introduce people to new concepts, whether that be low-level things like the C language or to the handmade ethos. And in particular, the C language seems like something that a lot of people have a barrier with. And I wonder, it sounds like you already started commenting on that, but could you talk a little bit about what the experience is like learning something like R or F sharp versus C? Is there a notable difference for you in the difficulty or the what's effective in these different domains?
Oh man. Yes. The answer is yes. And I've been trying to distill my thoughts on this to try to provide useful, actionable feedback for the handmade community. And C is rough. C is rough. And to provide context, and I know that some people love to rag on C, and I think that is disingenuous because you have to consider the context in which C was designed and created. Like, computers were minuscule in terms of their resources and what they were capable of at the time. And so a lot of the decisions that went into C were to accommodate the horrendous limitations of hardware. And so when you take a language like C and then compare it to something like Zig or Odin or Rust or something like that's a grossly unfair comparison. Like, that is decades of programming language research and decades of compute power difference. I'm sure that the original authors of C would have made some very different choices if they had had billions of transistors available to them to be able to do it. So, but the difference between like learning C, which is still a tremendously popular language, compared to learning something like R and F sharp. I think and this is going to also touch on like why I do the YouTube channel that I do. I think it's a very big ask if you have someone who has like an analyst background like me and saying like, hey, if you want to be a real programmer, you need to work in C. And the reason for that is that C is, you get hardly anything. Like, you want a priority queue? That's on you, sucker. You want to define the hashing of your struct? That's on you, sucker. And it's just like everything is on you. So if you are a hardcore developer and already have all this knowledge about like, oh yeah, I eat data structures for breakfast. Like, I love me some red black trees. Or like, you already have the knowledge and the capability of building all that stuff yourself. C's great because C gets out of your way. And one of the challenges I've had with F sharp and pushing performance is that F sharp has guardrails. I'm specifically thinking of like discriminated unions or unions in C. Like, in C, when I read the spec for like what a union is, I'm like, oh my gosh, that is insane. Because there's this like, oh, it could be a this or this or this. And when you unpack it, there's no compiler check whether you are getting the right case or not. Whereas F sharp was like, oh, hell no. Like F sharp is going to make sure that you are matching the correct case and getting the correct type out. So what I like about C is that there are no rules. And sometimes when you really know what you want to do, that's great. The problem, though, is that, and this is kind of, again, the feedback from the Handmade community. If you're wanting to bring the analysts, that kind of group of developers, and I'm trying to, like, I think of developers on this spectrum where you have your hardcore C developer and then you have your analyst. So the analyst for me is like, they write software, air quotes, but they're not the hardcore developer. If you're one of the analysts to move in the Handmade direction, the answer cannot be move to C. The answer has to be like, hey, how do you write what you're doing in a more handmade way? Because an analyst is wanting to answer a question. They have some question from the business. They need to write some software to answer that question, and they want their tools to be included, right? They don't want to like, hey, I need to write this really quick simulation to do something. They don't want the first thing they run into to be like, oh, okay, well, now you need a priority queue to do that. It's like, that's not built into the language? Nope. Good luck. You have to now write a priority queue. And I sure hope you know things about like cache layout and cache misses, because the performance of your priority queue is going to be really dependent on that stuff. They're like, no. Like, I want to like import a library or something and get my job done. So that is what I see as like the real challenge with trying to move people towards C. Like that's like you're asking them to take on a lot more than they really want to. They really just want to solve their problem. And so that's part of why I've tried to bring that Handmade ethos to the F sharp developer, because you're not going to get them to become a C developer, but you might get them to write code in a more handmade way that is much more performant. I think, and so this is part of why I'm really excited about languages like Zig and Odin, and also Rock, ROC, Rock by Richard Feldman. It's kind of like a different take, but they're taking performance very seriously. It's like these languages would be an easier thing for an analyst to move to because more batteries are included, and you don't have to deal with something like the borrow checker in Rust, which
Right.
for a new dev is going to be running into a brick wall of complexity. So
I think that was great. That was exactly the sort of thing I wanted to get from you about, I think in the handmade community, C it's not the only language that, has some respect, but it is sort of one of the defaults. And
yeah,
when you are in it deep enough for long enough, you can kind of become blind to like, what is everyone talking about? C is easy. Like we all know C. I don't know how there's no difference between learning C and anything else. And I kind of always been skeptical that can't quite be true, but it's easy to lose. It's easy to lose sight of what the journey looks like to learning programming when you're already that deep in to C, for instance. So let's actually talk about F sharp now. So the handmade people listening, like I said, are probably allergic to it. It sounds like it's probably related to C sharp. It's probably a managed language. So there's some basic obvious reasons why they're not going to be immediately switching to F sharp. But I still think it'd be interesting to lay the groundwork, because we're going to talk about how you do performance in F sharp. So knowing the framework of what F sharp is would be necessary for anyone to appreciate what that's about. So can you give us like an outline of the pitch of sort of the style of F sharp and how it's roughly implemented?
Yeah, for sure. So F sharp is a simple, concise language for writing correct, robust, fast software. That's kind of the spiel that they like to throw out there. I think a better description is that it is a pragmatic, functional first programming language. And what I mean by that is that what is a functional programming language? Like that term is very overloaded. And when people hear that, they think about Haskell. something, or like Idris, or like some of those other hardcore functional programming languages. That is not F sharp at all. It is very much from its inception designed as the working person's language. It's a language to get things done. It's not a language for like proving things, right? And so the way someone thinks about problems when it comes to F sharp is just data and functions. That's it. It's just like you have some data, and one of the things that makes F sharp nice as a language is it makes it very cheap and easy to define types. And so you find for the F sharp developer, often the way they start thinking about a problem is they start breaking it down into all the different types that they're meant to represent. And you generally do not like reuse types for like multiple purposes. You just kind of like, okay, well, I will have like, you if you're like in heaven forbid in C++ or something like that, like, you have customer and you'll have tons of fields and you might only end up using a few of them for like your use case. And F sharp said like, no, you have like validated customer, invalid customer, checked out customer. Like you would create a very descriptive domain for your problem. And then you would define the functions that kind of map between those types or do operations on those types. And so it's very much about distilling the problem down to what's your data and how do you want to operate on it? That's it. Now, stylistically, when you're writing F sharp, it is typically a functional first approach. And so what do I mean with that? Like you don't have like lots of methods on objects and you're mutating objects in place. No, like the default of F sharp is immutability. Like data is immutable and you have functions for transforming them, and then it makes it very easy to pipe results from one function into the next, into the next, into the next. And so that's part of the reason for the logo of F sharp is the pipe operator, where like given the output from the previous function, send it into the next function. And so it's very much about composing domains and composing functionality by gluing functions together and mapping between types. And so it's really intended to be simple. And there's this really funny graph that everyone's probably seen on the internet where just kind of like you have the noob who's just kind of like super simple code. And then you have the hump, which is like functors and monads and blah, blah, blah. And then on the far side, you have the expert and it's like really simple code again. F sharp really encourages you in the direction of keeping things simple. It has objects. Like you can have an object, which is like this piece. It is where you've like married some data and some methods, but it very much de-emphasizes object orientation. Like it has it out of necessity to support the fact that it is a .NET language. And I can start unpacking that in a sec if you want me to. But it is not how a F sharp developer would typically go about solving a problem. So it's like, no, we have inheritance, but we generally don't use it. We'd much prefer to use a union and say like, hey, I have an animal and there's like different cases of like chicken, duck, goose, or whatever. And like, that's how we start packaging up like, oh, this could be one of many different things. And that comes down to the fact that it has an algebraic type system. And I won't go into like the geekiness of that because I don't think that's what people really care about. But like that might mean something to somebody.
Yeah. To anyone who knows what that means, it helps give the flavor of the language. And I think even what you've described in terms of you define your data structures and your functions, that sounds actually a lot like C, except there's like .NET in the mix. I guess it would probably be useful to expand on what the .NET part means. So I think .NET would be a huge undertaking to like explain it in detail. So I think what would be most useful is I'll start by explaining what I understand. So this is, I think, representative of what someone in the Handmade community might understand about .NET who hasn't ever actually programmed on it, but just has heard about it for years. And then you can, clean up all my errors and fill in any details that are more relevant.
I gotcha.
So my understanding of .NET is that it's a lot like the JVM. So it involves some kind of bytecode that you compile to, and then an interpreter slash just-in-time compiler thing that deals with that bytecode, and then basically a giant API for operating system and data structure features. That's my understanding of .NET.
Yeah, and that's not inaccurate. The original idea of .NET was to create a universal platform for languages.
Mm-hmm.
And so when .NET came out, it has what's called the Common Language Runtime. And so when it came out, there's 20 different languages that all compile to .NET. Because when you compile something to .NET, you're turning it into the IL, the Common Intermediate Language, or just IL for short. And IL looks a lot like 86 assembly. It is very similar. And so you could see the purposefulness with that. They were saying like, hey, we want this intermediate representation to be like, we have abstracted the machine, but not much. So like, yeah, like you can see like, oh, there's registers here and this stuff's going on. And so it was Microsoft's idea of creating this one platform that does expose like the operating system functions and whatever, but many languages could target it. And so now you mentioned JIT. So yes, classically, most of the time, .NET has a JIT step. Recently, though, there has been this big push for native AOT, or native ahead of time compilation. So the idea is like, hey, I could write my F# or my C# or VB.NET, but then compile it to x86-64 or on like Linux or whatever. Like I could target a very specific operating system and platform, and it would take it all the way down to the machine code. And so that is becoming more of a .NET story right now. It's still in very much active development. You also have the idea of the Blazor technology, which is, again, relatively recent, but compiling .NET to WebAssembly. And so that's another way that it can be delivered. But like you've basically hit on it. It's the set of technologies. When you compile something to .NET, you're compiling it to the intermediate language. And then there's functionality that then when you want to run your program, it takes the IL and maps it to the machine that you're on. And so that's one of the nice things about .NET, if you're building for it, is that you've deferred that what machine you're actually compiling to the point that you're actually going to run it. And so the cross-platform story is relatively easy.
Right.
Because you've deferred that compilation. You haven't like said like exactly where you're running. It's at the time you want to run it that it will actually like map it down to the machine hardware.
Okay, so that's pretty useful. I think that clears up the stuff about .NET that we're going to need to know. So the other piece that I think is going to be useful before we talk about performance is to flesh out this aspect of F#, which is what kind of users generally would be using F#. You've already mentioned that it's analysts and simulation, so that might be the answer, but I don't know, it might be broader than that. That might be one category. So what is sort of the use case for F# in particular?
Yeah, that's a great question. It is much broader than just analysts. I came to it because it has a units of measure feature, which is you're able to annotate your numerical primitives with things like meter or second or whatever units. And then the compiler itself is actually tracking that stuff for you and making sure it's correct. Which when you're writing financial models and dealing with billions of dollars, that's really nice to have. But the uses of F# are actually much broader. So, I mean, there's tons of people doing web development with F# and line of business apps. It is used. So F# was first used outside of Microsoft, and I have to double check this, like Credit Suisse and Morgan Stanley back in the day when they were doing their financial modeling and stuff. And so it's used a lot in the finance industry. I worked at Rocket Mortgage for a while, developing software for their trading desk. And there is a large F# code base. I'm not sure how much more I can say about that. So like we see lots of financial institutions using it because it has it makes it easy to write correct and robust code that runs reasonably fast. But yeah, there's also like lots of web development going on, and anytime, and it's also used a lot for just kind of business logic or like ETL type workflows. We're just like, hey, I have some data, I need to do some kind of transformation and validation on it, and then like pump it into some other system. It's really effective in those scenarios as well because its design makes that idea of transforming data very simple and easy. And so it's generally used like anywhere you use a programming language, you could do it. Now, where it doesn't shine is things where .NET doesn't shine, right? So things like a microcontroller, like you're probably not going to get .NET running on some tiny piece of hardware, but it has anywhere that you could run .NET. F# is probably going to be a great answer for that. And so the community is very broad, even though I focus on a very, very narrow niche inside of it.
Gotcha. All right, so I think that's all the pieces sort of to set the groundwork. So now what I'd love to hear about is sort of what you focus on to bring performance thinking and handmade thinking into F#. And I think the spot that I'm most curious about first is sort of very technical and specific, and it's in the handmade community. As we think about performance, we focus a lot on CPU features like cache lines and memory speeds and branch mispredictions, and out of order execution means you think about data dependency or the possibility of switching to SIMD instructions to get a multiplier in your speed. So those are the kinds of things we think about in the handmade community a lot when we're talking about performance. And I'm curious, I guess, first of all, how much of that is translatable and how much of that doesn't really move over into like an F# .NET style performance thinking?
Yeah, another great question. And most .NET devs will never get there. And so I'm just going to be upfront about that. Like that's not the level that they're thinking about. What they're typically thinking about is things like heap allocations. When a .NET developer starts thinking about performance, they're going to start thinking about like, okay, well, how much am I allocating? How much is the garbage collector making my life sad? Things like that. But if you keep pushing the performance, and I think you've seen this in some of my videos, you definitely get to branch mispredictions. You definitely get to cache lines, cache evictions, and cache locality of your things. It's typically not what the .NET dev will focus on because their performance problems are more egregious than that. But can you get down there in the mud, right, and really fine tune your code to really take advantage of the CPU architecture and how things are laid out and how things are accessed? Yes, absolutely you can. And actually, .NET has a great story around this in terms of the benchmark.net library, which is a fantastic tool. And it's a library which allows you to take like a piece of code, you write a benchmark, right? You define your benchmark, which is just some method on a class, and you annotate it saying benchmark. And then you could add other annotations to it saying like, this is what I want you to measure, right? If you don't give it anything, it's just going to measure like, hey, what is the mean time to run this piece of code? What's the standard deviation, the variance, and kind of give you some general metrics around the performance of that code. But you're like, you know what? I really want to know about my cache misses. I really want to know about my branch mispredictions. And it will then, when it runs that, it will run your code repeatedly. And it has built-in statistical tools for measuring like, hey, do I have a statistically significant result or not? Do I need to keep running it? Because if you just run something once, that's meaningless. Like the branch predictor does not have enough information to know like how your code is actually going to run. Like, so it will run your code over and over and over, keeping track of the statistics about it in order to guarantee a statistically significant result. And it can report back to you all these hardware metrics. which I find incredibly useful because typically the way I work is that I have some larger system and I want to improve the performance of it. I will attach a profiler. So something like .trace, or there's some .trace is the one I use most of the time, or Superluminal, which was one that Handmade people might be more familiar with, which is a fantastic profiler. But that will help me isolate the piece of code that's giving me problems. Like, oh, okay, this is the piece of code that is slow. And then I will write a benchmark around that piece of code and run it and really hammer on like, okay, what is going on here? And then from there, benchmark.net also makes it easy to get the x86 that the .NET code mapped to. So you can see like, oh, this is the assembly that's running, and it will also try to associate branch mesh predictions to the different lines. Mm-hmm. So you could see like, oh, it's this, load line that's causing my cache misses most of the time. And then you can go trace that back to like, okay, what's this data structure? How is the data laid out in that data structure? Is there anything I can do about the locality to improve the chances that I'm not going to have a cache miss or not? So there's actually a ton of things that you can do in your .NET code to really take advantage of CPU hardware. It's just not what the .NET community typically talks about, which is the entire purpose of my YouTube channel. Because when I started seeing all this stuff in the Handmade community and how they're like talking about real performance, not to be like rude or deprecating to .NET, but like sometimes I chuckle about like .NET people talking about like, oh, we're taking performance seriously. I'm like, but really? Like if you're talking to me about like how we made something faster by putting a Redis cache in the middle, I'm like, get out of here. Like, don't even talk to me. But you can do so much, and the Handmade community makes it clear just like there are just unbelievable amounts of performance being left on the table, which is why I loved I love Casey and some of the videos that he puts out, and it's just kind of like, oh man, this one's going to make Twitter interesting for a few days. With his clean code, horrible performance. I'm like, oh, chef's kiss. That was beautiful stuff. Because I see what can be achieved, and then I go look at my F sharp and like, how do I get that out of F sharp? It's like, okay, now how do I translate that to other F sharp devs so that they can start seeing like, wow, there's a lot of performance left on the table? Because it's one of those things where like, until you see it, until it's like been made really explicit to you, you just like don't have the ability to perceive that there's a performance issue.
Yeah. I mean, just to weigh in on that, I would have assumed, even as someone who programs in C, and when I program in C, I do think about, can I lay this out so that the cache lines will be prefetched the right way and that kind of thing. I would have assumed if you gave me F sharp that I might as well not bother thinking about that, because it just feels like that would be an environment where it might not be worth it to bother. There's almost, to me, like a second layer of performance issues I have to think about first. So in C land, or in low level systems land, you kind of start from the level of how do you lay out your memory, how do you structure your loop, branches and all that. Whereas in F sharp, there's this extra layer. First, you kind of also want to make sure that you've thought about the garbage collector and anything else that might be performance stuff that sits on top of that, and you have to know how to clear those things out of the way, is my thinking, before I could even get to caring about the cache line. I don't know if you agree with that or not, but that's the feeling I would have if I was presented with the task of doing performance in F sharp. So I don't know. I put that before you. What do you think about that mental model?
I don't disagree with you. And this is a lot of when I coach people and teams on F sharp performance. The first thing you need to be aware of is how the .NET runtime does its job, and how does the garbage collector do its job. And so I agree with you. There is that layer. I'm not like, that's real. Now, if you never allocate on the heap, there's nothing for the garbage collector to do.
Mm.
And what do I mean by that? So much of the defaults of C# and F# and .NET are toward the, how to say this without getting in trouble. It is the safe but slow default. I'll say it that way. .NET was designed during a time when object orientation was hip. And so, man, does it love some objects. And man, does it love allocating on the heap like a mad thing. So, and on top of that is that the .NET Runtime has to, when you like allocate something on the heap, it's not just going to be the size of the fields of that object. It also has to allocate some space for some metadata to support things like reflection, right? So like stuff is just fatter on the heap, like by design. And man, that drives me nuts. So all of these defaults and all the tutorials and all the training material out there is going to push you in the direction of slow, bad cache locality, terrible things for performance. And people will say like, oh, but the garbage collector is really good and stuff like that. I'm like, yes, it is. The garbage collector is a phenomenal piece of engineering. But if you never create any garbage, there's nothing for the garbage collector to do. And so I'm agreeing with that earlier statement, but now I'm going to say like, and so this is part of what I'm kind of working toward on my channel is like showing people like there's another way that we could be managing memory, right? It's like you're never going to get around the heap. The fact that, hey, it's garbage collected, there is a heap, like you got to allocate somewhere, man. Like, and the stack is not this infinite resource. So what you can do instead, though, is these really common design paradigms that you will find in the handmade community or in game development. So like, you know what? I know I'm going to have a lot of, I'm going to just use chickens as an example. I just use it for everything. Like, hey, I know I'm going to be using this chicken type a lot. Instead of just defining it as some object that gets allocated on the heap, I'm going to say it's a struct. And then I am going to have this array that I'll call flock. And if I need like to store a chicken for a certain amount of time, I'm going to put it in the flock array. And the array is just this big block of memory that has plenty of space for all the chickens I will ever need in my program. And I can allocate, air quotes, allocate and deallocate chickens from this thing as I need to. And now the garbage collector just sees like, hey, I have this array. It never goes away. I have nothing to do. I have no work now. And so that's kind of a dumb example, but I'm just doing this extemporaneously. But it's just like, it's things like that where it's like, and change how you think about allocation instead of like tons of small objects on the heap. And this is kind of goes back to Mike Acton's talk where he just, what was the title of it? It's this really famous one where he's got the red Hawaiian shirt.
The data-oriented programming one? Yeah.
Yeah, where he just kind of ripped C++ a new one. It's great. But in it, he's like, think about the most common scenario and design for that. And so this is what I try to touch on the F# stuff is like, do you actually have lots of small entities? And I don't mean that in like an entity component system. I'm just talking about like, do you actually have lots of small objects, or do you actually typically work with collections of them? So instead of allocating 1,000 of these things individually, allocate an array of them. That is going to be so much faster. And it's so much faster for the garbage collector to collect that if it ever needs to. And so it's like, think in terms of your actual problem and how you're going to be working with this data. Don't just, okay, I'm gonna try not to like lambast other people too much, but like domain-driven design, right? It's one of those things that, again, is kind of hip in the F# community because F# makes it really easy to define types, and people are like, oh, I just love the domain-driven design. And I don't know if I'm like the grumpy grandpa on the side or something, but it's like, I'm I am fine with domain-driven design if your domain is the computation.
Right.
Like, how are you actually going to compute this thing? Because I think that domain-driven design has at great risk of falling into the same problem of object orientation, where they assume that the model of the world is a good model for how to write software.
Right. What I'm hearing you say, and this is something I've sort of tried to figure out how to articulate. So I'll give you my spiel on this briefly and see what you think of this take on it. But I call this whole phenomenon narrative-driven programming or narrative-oriented programming. And the problem with it is that you find out that any given program or any given problem, you can actually attach lots of narratives. And the method that, object orientation or, a domain driven, I like the sound of that in the sense that if you just say, what am I really trying to do? But if you took domain driven to be whatever the first narrative you came up for your problem was, just write that into the code. There's no guarantee that your narrative for what your problem is like is a good match for what a solution to it is going to be like. And that's sort of why I call that narrative driven. And I can't remember, I had like a different, sort of data flow driven where you're just thinking about, all right, here's the data we actually have, the data we actually need, and the machine I have for transforming it. Well, how do I play the game? Right.
Yeah.
Those are the sort of two different mindsets. And I think we're, in general, like I see the handmade community and broader performance, pro performance programming community as shifting out of narrative programming into this sort of data oriented programming kinds of philosophy.
No, 100%. I like that way of putting it. And I try to remain to have an open mind to these new ideas that are happening in software, because I think the moment that you close your mind off to new possibilities, like that's like a slow death, right? So I'm just like, I'm trying to not just like have this deprecating view of domain-driven design from the get-go. I like that statement, like narrative-driven design. Just like, no, like, because there's multiple narratives, and some narratives are more computable than others.
Right. Exactly.
And what I think that irks me the most when it comes to this whole phenomenon is that it's very, I'm not saying this is true of the Handmade community, I'm talking about like the .NET community. It's just like design discussions almost never mention a CPU. That is effing insane in my mind. And part of the reason I say that is from that background of chemical engineering and industrial engineering, where like these are engineering disciplines. And the whole art of engineering is taking the realities, the physical realities into account. If you're a civil engineer, you need to design a bridge. You don't think about the abstract concept of a bridge. You're like, no, where does the bridge need to be? What is the soil composition? How large is the span? Like, what is the stability? Is this in San Francisco or is it in Portland? Because San Francisco has more earthquakes than Portland. Knock on wood. I'm in Portland, for those who don't know. Or like a chemical engineer. Like when you are designing a chemical processing facility, you need to take the ambient atmosphere into account. You're going to design a very different facility in Arizona than you would in Anchorage, Alaska, right? So physical reality has a huge impact on your design. Whereas in the software development world, it feels like a lot of the time we kind of just completely divorce ourselves from the realities of where does our software run. Now, obviously that's not true in the Handmade community. That's the whole shtick. And I'm sure there are .NET communities where this is more of a focus. So I am speaking from my very limited viewpoint. So, be kind to me when you judge me. But I rarely hear people talk about the CPU and the physical realities of where things are going to run.
Yeah.
Which, again, kind of sounds crazy to me because when I was working at Rocket Mortgage, and we had these data pipelines where we had loans coming in and we were having to do some analytics on them. I'll leave it at that. And one of the first questions I asked is like, okay, well, where are these servers? what are the, and where's the database?
Mm-hmm.
Like what are the physical connections between these things? And like, because if you have performance targets, and we did, like with the,
Mm-hmm.
like, turns out when you're trading billions of dollars, like stuff needs to run fast. Who
Mm-hmm.
knew? So you have to take the physical realities of the system into account when you have these performance targets. And I think a lot of the time, the .NET community just assumes like, well, CPUs are fast, compilers are magical, so we don't really need to worry about that. And it just blows my mind.
Yeah, I think that the handmade community can definitely relate to that. Even in the native world of game programming in C++, that was sort of the revelation of Handmade Hero was like, hey, if you start thinking about the problem, I don't know that this always elucidates the issue as much as the like I'm trying out this narrative driven programming way of describing it, but the way of describing it as bottom up versus top down, where bottom up is, hey, let's start from looking at what we have and what we need to get out of it. That was, to me, it's just a huge mental shift that I underwent where I felt like I became capable of much more, which I kind of guess leads into a question that I also wanted to pick your brain about. So I think a lot of people, when they hear someone suggesting that they should take performance seriously, their assumption is, and there is a learning curve to that process. Like you have to learn about what to care about. You have to change what things you would reach for first. But do you feel like learning the performance stuff that you apply in F Sharp now has changed the way you think about the code you write, and has it made it more difficult to get code done after you've learned these things?
Ooh, ooh, that's a good question. Because sometimes I think about the curse of knowledge. And once you see something, you can't unsee it.
Mm-hmm.
And so there is an aspect of once you learn about performance, you there is a relearning process that has to go on. I think
Mm-hmm.
it's just kind of like, hey, because like anytime you start with a new tool, there's going to be this period where you're less efficient as you're getting used to the tool, and then you might end up being faster. That's what everybody claims about Vim, apparently. But with F Sharp, I definitely reached a peak early on where I felt like, oh yeah, I'm a good F Sharp developer. And then I learned about the handmade community and data oriented design and all that, and just like, oh, I'm a terrible developer. So then I was um, spending some time having to like rethink how I compose solutions or how I answered problems. And so I still feel that I'm kind of in the midst of that as well.
Mm-hmm.
But at the end of the day, I'm able to hit performance numbers that I was never able to hit before. And I think at this point, I'm now in the point of like distillation back down to like, oh, this is actually really simple again.
Mm.
Because for me, it typically, as I'm learning something new, it's hard, it's complex, and like all the things I'm thinking about is kind of like growing and expanding. And then I'll hit some critical mass or something like, oh, it's just this.
Mm-hmm.
And then the thing is kind of collapse back down again.
Mm-hmm.
I'm specifically thinking about something I was recently working on for our engine, where so the discrete rate simulation engine, and inside of it, inside of the heart of it is this solver. And the solver is actually the secret sauce that makes it way faster than anything else in industry.
Mm-hmm.
And this code is the most procedural thing you have ever seen in your life, right? And it like the performance, we want to be able to simulate like a year's worth of stuff within a second,
Mm-hmm.
and which typically means we have about 1,000,000 time steps. And so we have about, oh, does that come down to a microsecond or something? I don't, bad at middle math, but like, point is this piece of solver code has to be outrageously fast because it's going to be called all the time. And for a while, I was just really struggling with like, man, how do I like write this? And like all my F Sharp experience was kind of like leading me in these different paths and stuff. I'm like, dude, this is simple. You have a struct. That struct is called context, and it holds all of like the working data that you're working with. And you're just going to pass that by reference to these functions, and they're just going to do their thing. And you're going to put work that needs to be done on this queue, and you're going to pop stuff off the end, and you're just that's it.
Mm-hmm.
Like, and it's just like, oh my gosh, this is actually really simple.
Mm-hmm. Mm-hmm.
But it's just kind of like, it's just kind of, so that's where I think I'm kind of like on the other side of it now, where it's just kind of like, yes, I've had to spend all this time learning about performance stuff. And now having like struggled with it enough, like it like stuff's getting simple again. And for me, that's a sign like, oh, now I actually understand something
Mm-hmm.
because it's starting to feel simple and intuitive again.
Yeah.
But that is definitely a hump.
Yeah. Yeah. No, I probably ask a slightly leading question there. I'm really curious to try to sample from people, especially people who haven't fully finished the process or have only recently finished the process of sort of upgrading their programming with performance thinking.
Mm-hmm.
Because I think it's another one of those narratives of the handmade community, like the one that C is actually easy and there's no problem with learning it. Another one is
so hard.
Right. Another one that we have, I'm not as sure about. I'm not convinced that it's true or false. I'm very much trying to figure it out, which is that learning to program with performance in mind, it doesn't make it slower to achieve things. And I think that there are definitely specific cases you can focus on where you go, well, you could rat hole for a year on this one problem, and the non-performant thing would be to get it done in a day. But that's a little different from just having the awareness of programming in your head. So I think for people outside of performance-oriented thinking, they tend to look at it as, if I did learn all that stuff and didn't just immediately ignore it again, it would permanently slow me down day to day. And that has not really been my experience. It's much more like what I think you kind of painted there, which is that the learning process really does slow you down because you're kind of waffling back and forth between a new way of thinking and an old way, and you want to achieve performance, but then that makes you overcomplicate things. And I call this the phenomenon like trying too hard. Like you really want it to be fast, so you put in tons of effort to make it fast, and it still doesn't do the thing it needs to do. And then eventually you learn that like really what you want is the simple thing that's also fast, because then you can get it done. And you can sometimes get more done than you could have before because you would have made it more complicated when you weren't doing the performance. Like there are pros and cons to becoming performance aware, I think, but it does not seem clean and like cut and dry to me that performance slows me down. And so I've been trying to like figure out if the first time I asked this, I just gave it to you without telling you my view. But now you know my view. I wonder what you think about that thought process.
So what I experienced was kind of a need to unlearn things and permission to keep it simple. What do I mean by that? So like I talked about like, oh, well, all I'm really doing is I have this thing called a context. It's a struct. It's holding some data, which is just some references to arrays that I'm working with. And for me, the struggle was just like, is it really okay for it to be this simple? Because at the end of the day, often the most performant thing is the most simple thing. Mm-hmm. Because when it comes down to branch predictions, locality of reference, like arrays are wonderful when it comes to locality of reference. And so like the more like you don't need most of the time, you don't need these fancy data structures. You don't need these, I'm going to refrain from mentioning specific things, but just kind of like all these complexities that people get really excited about. And this is not just F sharp. Mm-hmm. This is pretty much any managed language is going to suffer from this. And like, even like Rust, you know, which is kind of heralded as like, you know, the savior for systems level programming, but fast. They make these really complex things easily accessible when really that's not what you needed at all. You're just like, hey man, I just need a stack and like I just need a place to put some memory and to move some stuff in and out, and like that's it. That's at the end of the day. But it's like once you learn about these more complex features, like your brain like wants to reach for them. Like there's this tendency just like, oh, because as developers, we often want to feel clever, right? Just like, oh, I thought it was this amazing thing. Like, oh, this is just this recursive tree descent parser, blah, 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 blah. Just like, bro, like, no, like, what are you doing? Like, keep it simple. And it's tough when you've been accomplished for writing complex things. And there's this amount of humility that you kind of need to swallow once you realize like, oh, I didn't need all that complexity. Like I thought I was being so clever. Just like, no, you weren't being clever. You were just using tools you didn't really need. Like the problem really kind of distills down to this. And there's this element of humility that you need to take on. Just like, oh, I don't need these fancy things that I thought I needed. It's relatively straightforward. And that's when I know that I've reached a new level is when I kind of fall back down the mountain. It's just kind of like, oh, okay, well, it's actually not that highfalutin thing out there. Like, who cares that it's a monad or whatever? It's just kind of like, bro, just like open the thing and like do the work. Like, that's it.
It reminds me of something. I had a high school math teacher who forbid us from saying that something was easy ever, just because the idea was if it's easy for you, that kind of what you're saying, that means you've gone to this new point of understanding. But the people around you who haven't seen it as easy are seeing this extremely complicated thing, and that's the only thing that they can use to grasp with the problem. And so it's frustrating though, because you want to say like, hey, don't be scared of this. It's actually going to be easy when you get there. So it's sort of stuck with me as, you know, it can be discouraging to say something is easy, or that it could be simple, or there's a straightforward way to do this. And at the same time, you want people to see that is the case, because it is kind of relieving to get there. You want to like find some way to lead them there, right?
Yeah. And that's, again, kind of like going to the purpose of the YouTube channel that I have. Like for me, like the YouTube channel is about helping to translate between like the handmade world and the F# world, and like showing people like, yeah, it is easy. Like, and this is like one of the things that I like emphatically think, like, so much of the time what we lack is the student isn't dumb. They just don't have the right teacher. And what I hope to do is to kind of pave the paths that I have walked for the people coming behind me. They're just kind of like, hey, you know, this isn't actually hard. You're not dumb, but like you might need someone to like walk you through it and unpack it for you, which is kind of really my heart with that content, is because like, yeah, it is so amazingly frustrating to be in the math class and someone talking about like, oh yeah, this partial derivative is relatively straightforward. I'm like, mother trucker, like it is not. Like, no, it is not. But like once you have the right teacher, and is it 3 brown, 1 blue? Is it 3 brown?
Yeah, I know who you're talking about. I don't know how many blues and browns it is now that you've thrown it out there.
But like his that is like the quintessential example of like the right teacher. Because for me, linear algebra was this like opaque, like no way am I ever going to get that. This is crazy. And then a few years ago when I found his channel, like watched his series on linear algebra, I'm like, oh my gosh, this makes so much sense now. Oh, this isn't actually that bad. But it took the right teacher to, like, I haven't changed as a human being that much. It's not like I just suddenly grew some new capability that I didn't have before. Like, no, I'm still the same person I was before, but someone with the right way of teaching and the right approach came along and just like, oh, I get it now. And so again, that's kind of like my heart for the YouTube channel, is to like help people get through those humps that I had to get through, and help people to understand how to do performance work and how to think about performance work. Cause that's one of the big problems. And I loved Casey's video on just like clean code, horrible performance. And then I did a response video where I kind of riffed on that with like, hey, let's translate this to F sharp and like talk about it. And it was, I mean, like I said, like that was no way. That wasn't like me like, oh, I'm like going to respond to him. Like, no, like this is great. And I want to translate this to F sharp and unpack it for you. Like, how is he thinking about this problem? And at the end of it, I said, like, what about just storing these in like 3 different arrays? And now you don't have to unpack this union case or not. And what's funny is I had several people reply to me like, oh, I never would have thought of that. And for me, it's like, are you kidding? Like, that's amazingly obvious. But that idea came from the handmade community. That came from game development process. It's like, hey, the way to get rid of branch mispredictions is remove the need for branching.
Right.
Like, get rid of the if statement. That was obvious to me, but I had already been on that journey. And the fact that people were now telling me who are coming behind me saying like, oh, I never would have thought of that. And just like, oh my gosh, like it's easy. But it's not. If you haven't seen it, you need someone to show you sometimes.
Yeah, with programming in particular, there's a certain obviously there's a bunch of complex stuff that people build for you to reach for. But if you boil it down to the fundamentals that you need just to have like a Turing complete thing that is reasonably close to what your computer can actually do so that you can just get some work done, the building blocks are particularly simple, but the space of ways you could compose those building blocks, for instance, just switching to 3 homogeneous arrays instead of 1 union array, it's actually quite a dense space. So it's, in a way, it's, once you've seen a thing, it feels like it is obvious, but there is definitely a matter of like, how am I going to scan through all the possible configurations of arrays and types and loops that I could conceive of here to find that one. And so I do think it makes a lot of sense to focus on how to teach these things from sort of 2 different angles. One, there's the making sure people have just seen some common combinations so that they're familiar with them. There's like a harder part, which is sitting with that space and like figuring out how you creatively come up with these things over time. I think that's something that I think I really like about video content personally, is that you can, like it's in Handmade Hero. So for context, what you and I are doing is kind of similar on our YouTube channels, where we have more prepared videos, and Handmade Hero is a lot more in the moment, watching someone's development process, the rough side of it. And for me, that was very valuable to see, like sitting with that giant space of combinations. And I think that's a hard thing to teach in a quick way. I don't know if you have any thoughts on that, or other things about what to do to make education on programming more effective. But it's something I think about a lot, and I assume you do too. So
Yeah, no, 100%. And it kind of touches on what I'm hoping to do for my next series, where up to this point, what I've done on my channel is I've typically focused on some very narrow niches, right? And like, hey, we're going to talk about, the stack or something like that. Or like, hey, we're going to do this whole series on optimizing a dictionary or a hash table by another name. That's a very kind of it's nice because it's a very constrained problem space. Like this is the only thing that we're really worrying about. And so the purpose of that is to like help the student not to have this huge context to think about. But okay, now when you actually want to build something proper, it's going to be more than just a dictionary, right? Like now you need to combine these primitives and these data structures with other things in a way that is going to be robust and reliable and performant. Like, okay, how do you do that? And what my intention with this next series is we're going to do a simulation. That's what I do for my job, right? And we're going to do a simulation of a farm. Now, what exactly I want to simulate about the farm, I'm not sure. But I'm going to start with what Matthew with 1 year of F sharp, 1 year of F sharp experience would have done, right? This is the naive newbie F sharp developer approach to this problem, right? And then what I'm going to do is tear it apart. And but my intention with that is to provide people with the questions that they need to do good design, because this is one of the this is one of the main problems I've experienced when absorbing software development talks is that people do great presentations on the answers.
Mm-hmm.
What were your questions? Like, what were the questions that you used to get to those answers? That's the more, in my perception, like that is the more valuable tool to give people. And this is what's like really rough about math education is that you're just often taught like, well, this is how to get the answer. Like,
Mm-hmm.
but like, what was your reasoning for like that set of operations? Like, nope, just do this and you're gonna be fine. And it's like, and often software development is taught in that way where this is the answer. Like, this is how you do it. But like, what are the questions that I should be asking that will help me find new paths? Because we are developing new software, we are answering new problems. There is not a predefined solution for everything. And so we need to know what questions should we be using to search for the correct answers. And so what I'm hoping to do with that simulation series is to equip people with those questions. And by the end of it, you're going to see something that is much more similar to like an entity component system style of like arrays and everything. But like, I want to show you how I got there.
Mm-hmm.
Because I think that's, we are not equipping people with the right questions is how I put it.
Yeah, I think that's pretty useful. I think that I have a sense for the kind of phenomenon you're talking about, and I haven't had a good way to talk about it before, but there's definitely, actually, this relates back to the very beginning of our conversation where I was saying that I have some amount of trouble with most programming books, and I think it's a similar thing, which is programming books seem to prioritize presenting an answer and spending a lot of time with that. Whereas videos seem to naturally, just the script of a YouTube video, it's just like this particular context lends itself to a little bit of setup and motivation in a way a book doesn't seem to do as often. But I don't know. Yeah, you're framing on making sure you're thinking about the right questions feels like a good way to articulate the difference between those two ways of presenting things. And I guess it also reminds me of what we were talking about with that feeling of the like almost finding permission to do something in a simpler way. There's this sense I have when I realize something is more complicated than it needs to be, that I had this deeper question I've been ignoring that basically comes down to why can't I do it the simpler way? Once I realize I really want to ask that question, then it all starts collapsing. And I think, yeah.
Yeah. Well, and I ask myself, why didn't I see that? Why didn't I see that? And that actually kind of hits on, so I recently did a blog post and a video talking about people that have inspired me. And one of the people that I mentioned in there is Jonathan Blow. Now, Jonathan Blow is not the .NET community's favorite person. But I don't know. I kind of respond well to like, you know, the harsh coach, like you suck or whatever, like get better. Mm-hmm. And just kind of like, yeah. And just like, cause I'm at the point where just kind of like, again, it's like, I appreciate it sometimes when someone's like, that's actually like really terrible. That motivates me. I know that doesn't motivate everyone, but so Jonathan Blow is a very particular flavor for people. But one of the things I really appreciate is years ago, as I was starting to learn about game development, I'm on YouTube and I see some of his talks. I'm like, this dude's really smart. And so I'm like, you know what? I'm just going to ping him on Twitter, right? I'm just going to write him a DM and say like, hey, Jonathan, like, how do I get better at programming? Like, what is it that I need to do to like improve? Or it's like, there's books I need to read or like, and it's just kind of like, and this is a long message. This is an overly enthusiastic newbie. Mm-hmm. And I'm like, I'd never really expected to hear back from the man, right? The dude's crazy busy, right? Couple days later, I get paragraphs of response. And really, it kind of comes down to what he was saying. Like, after every project that he does, he says he spends time reflecting on how good was that solution? Why did it take me so long to get to the answer? What is it that I could have seen earlier on that would have gotten me to that solution faster? So this period of introspection after each project, like what is it that what are the things that I missed that that would have accelerated my development? Like what is it that would have, made that insight clearer? Because he then is equipping himself with better questions for the next project. And so that's the same thing for me now, like as I've this kind of mantra I've adopted, just like, okay, what are the right questions that I should be having? And when I went back and like re-implemented the solver backend and stuff, just kind of like, okay, the question is like, what are the essential bits? And that's like a new question. Like I didn't start like, well, what is the domain of the solver? And like, just like, no. What is the essential bits of information that I need for this thing to run? Do I actually need, and what are like the fundamental operations that need to go on? Just like, okay, I have a stack where I'm putting work in and then taking it off. And then I have this queue that I need, and I need to track, am I recursing or not? Am I just like stuck in a loop between, because I'm like navigating these nodes or whatever. I'm just like, okay, how do I keep track of whether I'm recursing or not? Right. And just like, I'm just trying to think of some like really complex thing. And just like, no, just put a version number on your context. And each time you actually like have updated the state of something, like increment the version. And then when you're cycling through some nodes and you're in this part where you might be cycling, just keep track of like what was the version of the context the last time you got to this. And if it hasn't changed, you're recursing now. And just kind of like, that is an amazingly dumb and unsophisticated way of solving the problem, but it's flipping robust. And so it's like, it's that kind of stuff. We're just kind of like, man, what are the essential bits? And so I'm always looking for better questions for myself.
Yeah, I think that's really interesting. I look forward to how that series comes together. I'm a fan of the videos you've already done, as I said at the beginning, but I'm also a huge fan of sort of the deeper architectural design kinds of thinking. And so most of your videos have focused on that surface stuff. So I'll be really interested to see what your take on the deeper long form problem solving stuff looks like. But with that, I think I've covered everything that I wanted to chat with you about. I think this has been really interesting, and thanks for coming on.
Oh, thank you. I've really enjoyed it. It's been really fantastic. And so thank you for having me. It's been fun.
Yeah. Can you give the listeners some place? I've already mentioned the name of the YouTube channel, but if there's anywhere else where you're putting things out that you'd like people to follow, go ahead and let them know.
Yeah, no, the YouTube channel is the best place to get a hold of me. You can also email me if you have questions. It's just hi@fastfsharp.com. And so if you want the most rapid response, the email is the best way. I occasionally go on Twitter, but it's mostly just to post announcements about videos. So that's not really the best place to get me. But yeah, email or just pinging me on the YouTube.
All right, great. Thanks.